Hello, good evening everybody, and welcome to this presentation about A-level chemistry at Longroad Sixth Form College. My name is Simon and I'm the course team leader of chemistry at the college, and you can see my email address on the screen there. And I'm very happy to receive any emails from you if you have any questions remaining after this evening, or you can contact the college admissions department. The aim of this presentation is to tell you a bit about our course and a little bit about our approach to teaching it, and also to introduce some of our students who've come along to tell you about their experience. But before I do that, I'm going to introduce the chemistry team. So here on the screen now you can see the chemistry team. There's 3 teachers in total. There's myself and Zoe. We've been teaching together here for at least a decade, and so we've got lots of experience at explaining the concepts and helping students from all ranges of abilities with understanding and improving in chemistry. And we've also got Adam, who's recently joined us straight from Cambridge University. So Adam's come with a whole load of new ideas and the latest sort of theories about teaching. So we're a very dynamic team. And we've also got our excellent technician, Sarah. She's very experienced and she'll be getting your practicals ready when you join us. And she'll be making sure that the practicals work and that they're safe for you to carry out, both in terms of the chemistry itself and at this moment in time, of course, in terms of COVID. And although it's me that's doing the presentation, Zoe and Adam are available online. And so if you have questions, you can enter them into the chat box and they'll be able to get back to you in real time that way. Now, our course at Longroad is the OCRB specification, which is sometimes referred to as Salter's chemistry. And we really love this course, and we've deliberately chosen it for several reasons I want to try and get across to you. One of them is that it's been developed in conjunction with York University. So it's very up to the date, it's cutting edge ideas in it, and it's presented in context. And the context is really important because it makes it interesting and it gives you some idea of what you might do in the future if you go onto a research career in chemistry in this country, or if you study at university, the kind of areas you might be in. And so the course is broken up into 10 what are called chemical storylines, and I've listed a few of the ideas here. And the storyline is the context. So we study, for example, the destruction of ozone in the atmosphere in Ozone Story to learn about reactions and radiation and reaction rates. And we study what's in a medicine to understand the kind of molecules that take part in common drugs like aspirin and salbutamol and so on. So it's a really interesting way of studying the course, and it's called a spiral curriculum because you don't study all the bonding in one topic at the beginning of the course and never go back to bonding again. You study little bits of bonding in every topic. And so every time you study bonding, you learn a little bit more about it and you go into a little bit more detail and you develop your ideas. And that's a really great way of studying chemistry, especially in a situation now where we're going to be doing exams after 2 years. So it's an excellent way of reinforcing continually the ideas that we study. I wanted to try to show you an idea about how this spiral works and how we study things in several different contexts throughout the course. And I thought I'd say a little bit about colour, because colour is a theme that comes up several times in A-level chemistry, and perhaps it isn't one that is taught much in GCSE. So we might begin in October of year 1 with looking at flame tests, which is a very simple qualitative way of recognising which metals are present in a salt, because different metals give you a different colour flame. So I think that's sodium there, which is giving a sort of very yellow orange flame. But if you start to analyse that light a bit more carefully and you split it up into a spectrum of frequencies using a prism, you find actually it isn't one colour, it's several colours, and what your eye is seeing is the combined effect of all of those colours, and that's what's shown at the top of the screen. That's the emission spectrum of sodium. It's got several discrete lines in it, but every element is different. And so in year 1 we begin by looking at why is that? Why does every element give a unique spectrum? And it's because of the energy levels that the electrons are residing in the atom. And so we link that to our study of atomic structure at the beginning. So as well as just learning atomic structure, we can see its sort of practical application in identifying elements. And we then take that a bit further and look at perhaps how you can use spectroscopy to identify elements in a distant star or in the sun. And you can look at the light from the sun and you can see the same lines in the same places in the spectrum of light from the sun. And so you can tell what elements the sun is made out of, or you could look at a distant star and you could look at a star and realize that, you know, some stars have lots of technetium in the atmosphere, and of course they're too far away for us ever to go there, but by looking at the light we can determine what elements are present. And it's an interesting fact that actually helium was an element that was discovered in the sun, in the atmosphere of the sun, before it was ever found on Earth, but it was by this process of looking at the spectra. So that's the first time we'd encounter colour and where it originates from. But then when you go into the second year, we'd look at colour again in the context of looking at transition elements. So this is the middle part of the periodic table. Again, perhaps an area that isn't covered greatly at GCSE, and we look at these totally different elements here that introduce us to a whole new area of chemistry, of complex ions. And again, the colour of these ions originates from the electrons and their movement within different energy levels. And so the bottom there is showing you some of the shapes of the distributions of electrons around the metal ions in these elements. And we look at complex ions which have got small molecules like water and so on attached to the metal ion, and these are all very coloured in solution. And again, we can see the links of this into different areas of chemistry, so we don't just study that theory by itself. You can understand why some things like hemoglobin in blood is red, because it's got an iron at the centre of the protein that's binding the oxygen. And it's red because of the electron distribution in it, whereas spider's blood is a different colour and octopus blood is a different colour because they have different metal ions with different electron arrangements and different energy levels in their bloods. Then we go, perhaps later in year 2, December sort of time, we look at colour again because we start to look at a practical application of it. And this course is very big on practical work. It's a key element of the Salters chemistry, which is another reason why we really like it. But having understood something about how colour is formed, you can utilise the colour that's absorbed by metal ions in solution to determine how much of the metal ion is in a solution. So this is a technique called colorimetry. And one of the practicals we do for the practical endorsement in the course is that students plan their experiments to determine how much copper is in a sample of brass, and they dissolve it and make a solution. And then they can look at the absorbance, how much light is absorbed by that solution, and that will tell them how much copper was in the solution and hence how much was in the original coin, because the more of a metal ion you have in the solution, the darker the colour gets and the more light is being absorbed by it. So there's a sort of practical application. And then again later in year 2, so March year 2, this is the last topic we do, but it's all about colour. And we look at this time at organic molecules, and you can see some really large organic structures. These are based on carbon atoms at the points in that structure, but very large azo dye structures in the top corner, and they give rise to some really brightly coloured substances, dyes, and you can see there's some sort of amazing colours in the dyes in an Indian market there. But the colour is caused by electrons again being delocalized in the benzene rings, and I've got benzene on the right hand side there in a little sort of box on its own. Benzene is a really key molecule at A level, but it's got the ability, or it does have delocalized electrons that can move around the ring, and when you connect several rings together you can get a coloured compound. And so again we see colour in a different context, reinforcing what we know about colour already, reinforcing what we know about bonding already, but taking it in a new direction. And while I've got benzene on the screen, I should say it's a really key molecule because of its interaction or its involvement in lots of drug molecules. So aspirin, salbutamol, paracetamol, all these kinds of medicines have got benzene rings in. So again, studying that gives us an insight into the applications of those drugs too. So that's the sort of content and a little bit of an insight into how it's taught and what's unique about the Salters way of teaching it, that you cover colour in lots of different contexts as you go through the course. I have to say a little bit about the assessment. It's 100% by exam, so there's no coursework that contributes to the marks. The exams are all at the end of year 2, so but that's a good thing in many ways because you have the whole of the 2 years to adjust to A level and learn and get better, and then you're assessed at the end. We also have a practical endorsement, which is there's a minimum of 12 experiments you have to carry out. We actually do far more than that. We do more like 25 to 30, but we cover the requirements of the exam board's practical endorsement, and that you can pass or fail that practical endorsement, and that appears on your certificate as well. It just doesn't contribute marks to the grade. And then I've listed there the very precise grade boundaries that the papers have, or the sort of percentages weightings that the papers have. And there's 3 papers, but the Salters model is that all the chemistry can come up in all of the papers. What's different is the type of questions. So in the fundamentals of chemistry paper, you get some multiple choice questions and some short questions on anything in chemistry. In the scientific literacy, you get questions on anything, but they're slightly longer questions, and you have an article that you have to answer questions on, but you get the article in advance and you can prepare for it. And there's a practical skills in chemistry paper as well that brings in the practical work that we've done. And again, that's a really good way of examining it, in my opinion, because that's how you would work in real life. You wouldn't study chemistry in little bits in isolation. You would study chemistry and you'd be bringing in bits from all areas of chemistry, and it makes sense to learn and practice the assessments in that way as well. Long Road gives you the opportunity to design your study program in whatever way you like. So you can combine any combination of A levels that we offer, and you can combine them with diploma courses as well, or extended certificates. And that's summarised on this slide. So the A levels are shown as purple circles, and the diploma courses and the extended certificates as red circles. But most of our students, I've put the blue box around it in the top left corner. Most of our students do A level chemistry along with 2 other A levels as well. And it goes, you can, like I say, you can choose any other A levels to go with it. I mean, common combinations would be biology, physics, maths. Obviously the science type subjects overlap very strongly with chemistry, but also a lot of students study it with psychology and geography. And we also get lots of students who do history and English and other things as well. And then a few of our students will study chemistry, perhaps alongside an extended certificate. So that's the pink box around the bottom right hand corner. And the most common things there quite often is computing, which the college offers as an extended certificate, and also criminology. And obviously if you're interested in a route into perhaps forensic science or analytical chemistry, sometimes criminology is a good subject for you to pick with it. So those are the combinations we do, and you can tune your combination to match what you want to do in the future. We offer obviously not just the teaching of the course itself, we try and get our students involved in a range of other enrichment activities. And obviously at the moment we're slightly curtailed by COVID related restrictions, but I've listed here the things we've done recently that give you a sort of indication of the types of things we would do. So every year we'd arrange some external speakers, perhaps some lab visits to look at production facilities, speakers in from the Royal Society of Chemistry. We carry out the Chemistry Olympiad, which is a sort of international chemistry competition. We help our students prepare for that, and the Cambridge Chemistry Challenge. And we have quite a few interactions with University of Cambridge students via the Stimulus project. So they come in and help our students and give them some support in the lessons, and also communicate what their courses are like at university. We have careers guidance from the Royal Society of Chemistry, and with the rest of the department we organise University Open Days. So lots of other things you can do in chemistry as well. And we're particularly pleased to be offering an extended project in chemistry. An extended project is like an AS level. It counts as much as an AS level, and it can be counted towards university applications. And it can be in anything students wanted to be in, but we have the opportunity to offer you the chance to do it in a practical chemistry project. We've got really well equipped labs. We've got loads of extensive chemical supplies. I think when we last added it up, there were over 500 different chemical substances in our store cupboard. So a huge range of things you can do, and all of the chemistry staff have got some research experience from our own PhDs and master's courses that we can pass on and help our students. And you can pick something you're interested in to research further. So here are the 3 students from last year who did the extended project. So Oliver looked at a method, devising a method for measuring the rate of reaction between zinc and acid, which sounds quite straightforward, but actually was really complicated to get good quality data and devise a method that would account for some of the problems that are associated with doing a reaction in solution. Alessandro made a really complicated synthesis of aspirin starting from anthranilic acid, which was a practical that goes well beyond what we normally cover in an A level. So he really went into depth with that, and it was a real achievement to have made some aspirin that way. And Cherub looked at also synthesizing aspirin, but looking at perfecting the method for it and recrystallizing and testing the purity of the product. So there were 3 really excellent projects, and we'd really like to offer more of those in the future. To give you an indication of where our students go, I mean, they go into all kinds of courses in the future. Chemistry is a very highly regarded subject by universities and employers, so our students do lots of different things, but I've listed here some things that are sort of closely related to chemistry that our students do, and the sort of places they go. So you can see that chemistry or chemistry and molecular physics, quite a lot of students going to biochemistry, pharmacy, environmental science, quite a few also chemical engineering, chemical physics, medical bioscience, biomedical science, physiotherapy. They're all subjects that would use your chemistry quite closely. You can see there's a real range of universities there, including some Russell Group universities as well. And to sort of focus in on 3 in particular, I thought that would illustrate those sort of ranges of things that they do. I've picked 3 recent students here. So Sabrina, who's previously been at Linton, she did superbly in her A level. She got 2 A stars and an A. She went on to do medicine in 2019 at Keele. And then Nathan, who'd come from a college or an academy rather, quite a distance away from Cambridge in the first place, but he did really well and got 3 Bs, and he went to do chemical engineering at Swansea. So he's using his chemistry very closely. And then Ali from Abbey College in Ramsey, she got ABC for her A levels in 2017, but she went down a different route and wanted to go into a more applied route, and so she's gone to a degree apprenticeship at GSK. And so you can see our students go into a range of things. Many use chemistry, but they can also go into very competitive courses and also into sort of applied routes more into employment. So a range of different destinations that they go into, but we're really pleased with the progression that they make here. Right, now at this point I want to bring in our student panel, because I'm very lucky to have several students waiting here to tell you all about the course and how they found it. And let's see what their experience is. So I'm going to start first of all with Paloma. So Paloma, I think you're just about to appear on the screen. There you are. So Paloma, if you could introduce yourself and tell us what you're doing at A level first of all, that would be great.
Hi, I'm Paloma. I'm a year 1 student and I'm taking chemistry, physics, maths and further maths.
Fantastic. And can you tell us why it was that you chose chemistry for A level?
I chose chemistry because I always wonder about how things are made, how they work, and what happens if you change that. And chemistry just gives me those answers in general, so I'm always fascinated by the subject.
Fantastic. And what's been your favorite thing about chemistry so far?
That I learn something new in every single class, and it's always a lot of fun. A key part is that the teachers are really good here at Long Road, and I just find myself wanting to learn more and more.
Brilliant. And could you tell us something about what a typical lesson involves? You're now sort of a term into college nearly. Can you tell us what sort of typical lesson is like?
Right. We start off by checking our prep work, and then we're introduced into a new topic. And here's when we take notes and we discuss it as a class. And then we're given a handout that we can work on individually. And during this time is usually when I ask questions to my teacher, and you can also talk with people nearby.
Great, so that's what we're aiming for, is to have some collaboration between you and the people you're working with. That's fantastic. You also mentioned preparation work at the beginning. Could you just tell us quickly what that involves?
Well, I find it really helpful because it gives you like a little taster of what you're going to learn in the next class. So you get a little heads up about it, and you can also prepare certain questions that you're still curious about.
Fantastic. Well, thank you, Paloma. I know you've got to head off to the physics session now, so thank you very much, Paloma. And I'm going to bring in Clara next. So Clara, you should be on the screen now. So hello, Clara. Could you introduce yourself and tell us what you're studying for A level?
Yeah, I'm Clara. I'm taking chemistry alongside biology and psychology.
Brilliant. And can you tell us also why you chose chemistry?
Well, I just really enjoyed chemistry at GCSE, but it was always a little bit too much just about the facts, and I wanted the details, and I wanted to understand the things behind the chemistry that we'd learned about. So A level, it just gave me more details, and I wanted to take it there.
Great. And is there a topic that you've done that sort of illustrates that, how you've understood something better at A level?
Yeah, we've done the periodic table at A level. So we've learned about the history of the periodic table and atomic structure, and we did that in GCSE, but it was never very in detail. And I remember it was just, you remember the different people and you remember the facts about them, but we've learned in A level, we've done all the experiments they did, and we've done why they matter, and it's just very interesting.
Good. I mean, I think that's something we hope people are going to find out about A level, is understanding a bit more about the reasons how these amazing facts about atoms are worked out, and how people know the structure of these incredibly tiny things and how they all link together to form something like the periodic table and the patterns in there. Could you also tell us, Clara, a little bit about the sort of work you have to do each week, so and how you're finding the workload at the college?
I'm finding it really good, really manageable at the moment. We have, as Paloma said, we have our prep work that we do for each lesson, and then we have work that we have for each lesson, and then occasional homework. But I think the work's a really good amount of work. It's very balanced, so there isn't too much, but you know that you're understanding everything, and you know that you have enough work that you've consolidated everything you've learned.
Brilliant. And that's something I'm glad you feel that way, because that's something we're kind of hoping to make possible, that you'll do the work you need to do to learn the techniques and learn the skills and move on, but you've got plenty of time for your own independent work as well. Okay, thank you very much, Clara. I'm going to go and talk to Liam now. So Liam, I think you're on the screen now. So Liam, if you could tell us what you're studying and which school you're from in the first place, that would be fantastic.
Hello, I'm Liam Denise. I'm studying, as well as chemistry, biology and geography, and I came from Sawston Village College. I chose to do chemistry because I'm interested in doing a career involving environmental science, and a lot of chemistry has a lot to do with environmental science. For example, biochemistry, which is in the course.
Brilliant. Okay, yeah, so we do quite a bit of biochemistry in the sort of beginning of the second year of the course. We'll look at sort of DNA and RNA and things like that. So that's great. Thanks, Liam. How have you found studying chemistry at college compares to studying at GCSE?
It's a lot more in depth. Like in chemistry at GCSE, it was really giving a quick glance over some things like energy, like energy levels and stuff. You just learned the simple GCSE knowledge. Like there were there were 2 electrons in the first shell and 8 in the second, and so on. And it's also more, it's more actually real life relevant. It's less just stuff you're supposed to remember and really just use for the course. It's stuff that you can use in real life.
Okay, great. Thanks, Liam. And we were talking earlier on about how you'd been finding chemistry. Could you tell us a little bit about the practical work you've done? I've said that's a sort of key part of the course. How have you found the practical work so far?
The practical work's quite interesting because it feels like a proper experiment where the result will actually surprise you, rather than in GCSE where you kind of know what you're going to get, or you can guess already.
Okay, well that's also a good thing. I'm glad you sort of feel like that, because one of the things we're trying to train you up for is to do real research in the future, where you don't know the outcome in advance and you have to try and reason out what's been happening. So that's brilliant. Well, thank you very much, Liam. I've only got a few minutes left, so I'm going to go to Alex next. So Alex is actually in year 2, and Alex, I think you're now on the screen. Could you just tell us a little about yourself before we get going?
Hi, I'm Alex. I came from Sawston Village College, and I do maths, physics and chemistry, and I'm year 2.
Great. And can you tell us, now you've obviously done quite a lot of the course, and what's been your favourite thing about chemistry so far?
The favourite thing is probably to go along with the practicals and how the lessons are taught in general. So as Liam said, the practicals are very much on you, especially in year 2 when we kind of get given a sheet and say we need to follow this as closely as we can and use our products in that way. And it sometimes goes really well, and sometimes you can spend half an hour doing something that's completely wrong, but then you go along and redo it and learn from what you've done, and the skills you learn are applicable to every subject.
Yeah, great. Well, it's definitely a learning process, isn't it? Nobody is expecting everything to go perfectly. That's great. Now, chemistry is definitely well known as a challenging A level, and there might be people watching and thinking, is it the right thing for me? Can you tell us what sort of support you can get at the college?
So some parts of chemistry are very hard, and you won't get them on the first round. So there's things like Study Plus, where you go along on a Tuesday or Wednesday afternoon for an hour and a half with your questions, and you can sit with your teacher and some of your friends and be shown how to do it properly. And it's sometimes easier than the lesson because it's almost like one-to-one, or you can have kind of very small classes of it. And your teacher's always happy to answer any questions you've got, so send them an email whenever and they'll be back to you very quickly.
Brilliant, that's great. And then on my final question on a sort of slightly different subject really is how have you found studying chemistry sort of socially? Has it been easy to make friends while you've been here?
Yeah, it's probably been the best subject to make friends in because of the practicals we do. So like this week we've done practicals quite a lot recently, and because of the lockdown we've got them all over with, but we've done them really well, and speaking to all the friends and people, especially in year 1, to learn about it is really good. And then if you're not sure, the group that's next to you might have done it properly or in the better way, so you can speak to them about how to do it, and it's just a good way to interact and make friends.
Yeah, that's brilliant. I mean, I think that's one thing we really try and encourage people to study together in the lesson and out of the lesson as well. I think that's a really important way of supporting each other. So fantastic. Well, thank you, Alex, and thank you to all of the students who've taken some time out to come here. I know you've got lots of work and things to be getting on with, so it's great that you've spent some time coming to talk to us tonight. So thank you very much. So there are 2 opportunities coming up in the near future. So in June, we're going to have some welcome days. So if you're going to potentially be a student with us, you can come to the college and you can spend your day here as a student. You can try out some different subjects and meet the staff. So we really hope we'll meet lots of you in June. And then we're also hoping to host some open evenings in June that we normally do in the summer. So in much better weather, and you can look around the site of the college and see what it's like in the sunshine. And although it's aimed at year 10, obviously we know that students currently in year 11 haven't been able to come into the college yet. So we're really hoping you can come to the campus before you have to start here. You can come and have a look around and meet all the teachers in the different departments. And if you have questions remaining, you can still ask them at that point. And then finally, other ways to stay in touch with us at the college. We've got lots of different ways in which you can find out information. So these are sort of summarized on the screen here. We've got the website, we've got a Twitter account, we've got a Facebook page, and we've got an Instagram account, I think that is. And there's also 2 email addresses there and a phone number that you could send any queries to. So I want to thank you all for spending the time to watch this presentation. We hope to see you in the college in person in the very near future. And I'm going to finish the meeting here, and I wish you all the best for your GCSEs.